number 5, what we want to do is solve this following integral, and we're told that we have to use trig substitution and without using any u substitution. So if we're going to use trig substitution here, here's our hallmark of trig substitution. We have a number minus a variable squared. Remember, you have to have a variable squared and a constant with some combination of plus and minus to use trig substitution. And because we have constant minus variable squared, remember that that clues us in that we want to use the substitution x equals sine theta. So for now, we're not going to worry about this x minus 3. We'll deal with that when the substitution comes. So therefore, our derivative substitution would be cosine theta d theta for dx. So now we just need to figure out what can we do, what happens when we do our substitution. So I'll write that over here. So x is sine theta, so here we have sine theta minus 3. If x is sine theta, 1 minus sine squared is cosine squared, and the square root of cosine is cosine. And dx was cosine theta d theta, so we were multiplying by another cosine. So we just have cosine squared theta d theta. And now this right here is our integral in terms of theta. So now we need to figure out how can we solve this integral. First thing we're going to want to do definitely here is to distribute. So we're going to get the integral of sine theta cosine squared theta d theta. I'm going to split this into two integrals right away. So we have minus 3 times the integral of just cosine squared theta d theta. So that was just distributing this cosine squared to both terms. Now we have two integrals. Now we're going to have to solve each of these in a different fashion. So these are turning into now our trig integrals. Remember, we had rules for things with secant and tangent. We have rules for things with sine and cosine. Some of these, you don't really need to memorize the rules. Some of these are kind of obvious. Like, for example, this first one, we have the derivative of cosine right here in the function. Since the cosine is the one that's squared, we want to call that one u. And since the derivative of cosine is sine, that's going to go away. So in this case, we want to use u substitution, where u equals cosine theta. Nothing real special to be done with that one. Over here, though, the integral of cosine squared, we can't really just do at face value there, because we couldn't do u substitution. We don't have anything to base it off of. And changing this into, for example, 1 minus sine squared would leave us in the exact same problem, so that's not going to help either. So what we're going to have to use there is we're going to have to use that reverse double angle formula, or the power reduction formula, I think is what it's called there. So here's the formula. I'm going to write it at the top. You have cosine squared of theta is equal to 1 plus cosine 2 theta all over 2. And if you don't remember those, which I honestly suggest not memorizing those because there's a lot of them and they're really confusing because a lot of them are pretty similar, you can always just get this from the double angle formula. If you remember the double angle formula for sine and cosine from back in Calc 1, all you're doing is rearranging that to solve for cosine squared instead of solving for the double angle. So, I mean, you can just memorize them that way also. So we can do that here. And since it's all divided by 2, we can just put that in front of the integral. So we can really make this part 3/2 integral of 1 plus cosine 2 theta d theta. So let's solve both of these integrals. So if this is u equals cosine, our du is equal to negative sine theta d theta. You can see sine theta d theta right there. This is going to work out fine. We just have a negative sign that we're going to have to put in front. And we're going to get u squared du for that integral. For this one over here, now this is definitely doable, because when we have a double angle or any constant there, that's just a constant of integration that you can divide by. That's no problem at all. So here what we're going to get is negative 3/2. When we take this integral, we're going to get theta, because the antiderivative of 1 is just our variable, whatever we're using, in this case theta. So the antiderivative of cosine 2 theta is going to be sine 2 theta over theta, or over 2. So remember, it's the opposite of when you're doing differentiation. And that only works when you have a constant, but when it does, you just divide by that number. So we just need to figure out what this one is, put them both together, and then we'll be fine from there. So what we're going to have here is the antiderivative of u squared is just u cubed over 3. That was negative because we had the negative sign out there. And then we have minus. I'll distribute this here. We're going to have 3/2 theta minus. So we have 3/2. We have extra 2 on the denominator here. So we have 3/4 sine 2 theta. Last thing we need to do is u was cosine. So let's write this all in terms of theta. So we have cosine cubed theta over 3 minus 3/2 theta minus 3/4 sine 2 theta. Alright, so the last thing we need to do is put it all back in terms of x. So in order to do that, we need to, and if you notice, none of these ended up being just sine of theta. So we need to set up a triangle and solve for our other trig functions. Now the one thing that we can do that can help us a little bit is that the double angle you're never going to be able to figure out in terms of x. You're always going to have to use a formula for that, but thankfully that one's not too difficult. Sine 2 theta, let's put it up here as another identity. Remember that that is 2 sine theta cosine theta. So if we replace this sine 2 theta by that, we would get minus 3/2 because the 2 would cancel out. Sine theta cosine theta. So you can see here, we know that sine theta is x. We don't know what cosine theta is, and we have that in 2 places, and we don't know what theta is. So I'm going to erase this previous part and set up how we can figure out theta in terms of x. So if x equals sine theta, well, to solve just for theta, we can just do the arc sine. So we know that theta then is arc sine of x. So that takes care of this part, but we need to know what cosine is also. So remember that sine theta would give you a triangle, and if sine theta is equal to x, that means that the opposite over the hypotenuse has to be x, which tells you then that our opposite must be x and our hypotenuse must be 1. And of course there's infinitely many ways you could actually set that up so that the ratio is x, but obviously that's the easiest way. By Pythagorean theorem then, the third side of that triangle is going to be square root of 1 minus x squared. Now one thing you can always, if you've done a lot of these problems, you've probably noticed, that last side is always going to be what your trig substitution was in the first place, because if you remember, this whole part right here simplified down to cosine theta anyway. So if you notice that, and instead of doing this triangle, you realize that that was true from your trig substitution, good job, because that's going to be easier. But in any case, if you use the triangle, cosine is adjacent over hypotenuse, so we're going to get root 1 minus x squared over 1 right there. So finally this, now written completely in terms of x. So we have cosine cubed, so let me write that as a fractional exponent instead, so that'll be easier to write. So we have 1 minus x squared to the 3/2, because we have square root, but we're cubing it, over 3. Minus 3/2 theta. Theta was just arcsine of x. And then we have minus 3/2 sine theta cosine theta. So sine theta was just x, and cosine theta was here. So we have x times 1 minus x squared to the 1/2. Finally, plus c, because we had an indefinite integral. So finally, now this is all in terms of x, and that would be our solution to doing this with trig substitution.